Good morning, everyone. Today we're going to get to one of my favorite topics, and that would be developing additional trigonometric identities. Now we're going to talk about 3 different ways to verify trigonometric identities. The first one is algebraically. Now, one of the things we have to remember when verifying trigonometric identities is we're basically proving that one side is equal to the other. So we can't assume that they're equal. And because of this, we cannot cross the equal sign. Again, I repeat, we cannot cross the equal sign. Again, since you're trying to prove that both sides of the given equation are equal, you cannot use any properties of equality because we don't know that they're actually equality. We cannot assume that they are actually equal. So some strategies when verifying trigonometric identities is to work with the more complicated side of the equation first to try to make it to match the simpler side. We're going to simplify both sides until they match, and we can look to factor. We can rewrite everything as in terms of sine and cosine, which is a very popular thing from yesterday's notes. We can look for substitution, perform indicated operations such as adding, subtracting, and rationalizing. And I am ready to get started. I hope you are too. So in example number 12, we have sine squared x minus 1 over sine squared x is equal to negative cotangent squared x. So first thing I notice is that this side definitely looks a little bit more complicated than the right side. So I'm actually going to start with that side first. And if I look at the top here, I see that there's sine squared x minus 1. Now remember from yesterday that when you have something squared and you have a 1, I want you to start thinking Pythagorean identity. In fact, sine squared x minus 1 is equal to negative cosine squared x. So all we did was we found out that negative sine squared x minus 1 is equal to negative cosine squared x due to the Pythagorean identities. Okay, I'm going to keep track of what we're doing over here on this side of what identities and what things we're using in order to solve. So now we have negative cosine squared x over sine squared x. Well, if you look back up to your quotient identities, cosine over sine is cotangent. We're looking for cotangent squared x, actually negative cotangent squared x. Well, if cosine over sine is cotangent, then cosine squared over sine squared has to be negative cotangent squared. So we have negative cotangent squared x is equal to negative cotangent squared x. And we got there by using one of the quotient identities. And guess what, guys? We have actually solved this whole thing. We proved that one side is equal to the other. And it was only 2 steps. Okay, so not all of them are only 2 steps, but I thought we'd start off a little bit on the simpler side. So next we have cotangent x times cosine of x is equal to 1 over tangent x secant x. So what we're actually going to do here is we're going to start with this right side because anything with a fraction is usually more difficult in everybody's eyes. Okay, so what I'm actually going to do is I'm going to break this up. So when there's multiplication, you can actually break up the denominator into 2 separate things, because this would be 1 over tangent of x times 1 over secant of x. Right? Multiply these together, you still get 1. Multiply these still together, and you're still going to get tangent x secant x for the denominator. So all we did was we broke up the denominator. Okay, I'm not going to attempt to spell that right now. Okay, so now that we broke up the denominator, what we're going to do is we know that 1 over tangent of x is actually cotangent of x due to the reciprocal identities. And we also know that 1 over secant of x is equal to cosine of x because of the reciprocal identities. And just like that, guys, we actually found the other side. So we're done. Okay. So again, we're only doing 2-step ones right now. We are going to be moving to some more difficult ones. Okay, so now on number 12, I see something a little bit more tricky. Okay, because now we have secant squared y minus tangent squared y is equal to tangent y times cotangent y. So what I'm going to do is I'm actually going to look at the left side of the equation first. If you look at your Pythagorean identities, you see that secant squared y minus tangent squared y is actually just equal to 1. And how did we get that? That was Pythagorean identity. Okay, so we know that the left side is equal to 1. So let's look at the right side for a second, because we know that tangent and cotangent are reciprocals, right? tangent of y is just is 1 over cotangent, and cotangent is just 1 over tangent of y. So tangent of y times 1 over tangent of y, this was because of the reciprocal identities. We know that that is also just equal to 1. So now we've simplified both sides to equal 1. We are done. We proved that the sides are equivalent to each other. Okay? Okay, so number 13 looks like a doozy, and this is why we had you guys do some of the practice for the prerequisites. So I have 1 over 1 minus sine x, 1 over 1 plus 1 over 1 plus sine x is equal to 2 secant squared x. Well, the left side looks a lot more difficult because we have fractions. So what I'm actually going to do is I need to find a common denominator here. So what I'm going to do is I'm going to multiply this first fraction by 1 plus sine of x, both to the top and bottom. And we're going to multiply that 1 minus sine of x. And then we're going to find the common denominator over here by multiplying this fraction by 1 minus sine of x to the top and bottom. Okay, and here we're just finding common denominator, right? Find common denominator. Okay, so now we have 1 plus sine of x over 1 plus sine of x, 1 minus sine of x, and then we're going to have 1 minus sine of x after we distribute here, all over 1 plus sine of x, 1, that's a 1 minus sine of x. So now that we have a common denominator, I'm going to add it. So now we have 1 plus sine of x plus 1 minus sine of x, all over 1 plus sine of x, 1 minus sine of x. If you look at the top here, these two sine of x's cancel out just to be, and then 1 plus 1 is equal to 2. So now we have 2 over, and then I have 1 minus sine of x, 1 plus sine of x times 1 minus sine of x. This is a difference of squares, so when we multiply it, we're going to get 1 minus sine squared x. Now I'm running out of a little bit of room here because I didn't think this through. So what we're actually going to do is, see this 1 minus sine of x down here? We know that that's a Pythagorean identity. That is actually equal to cosine squared x using the Pythagorean identity. So from here to here, we use the Pythagorean identity. And then what is 2 over cosine squared x? Well, that is just 2 secant squared x because cosine is the reciprocal of secant. So from here to here, we use the reciprocal identity. Oh boy, we went all over the place here. We use the reciprocal identity here, and I just ran out of room, and I'm not going to mess around with it again. Okay, so we actually proved that the left side is equal to 2 secant squared x. So we have officially proved that one side is equal to the other side. Okay, so we're starting to get a little bit more difficult. I'm sure you guys noticed now. So now we have, in number 14, we have secant squared theta minus 1 over secant squared theta is equal to sine squared theta. Now there's a couple different ways we could do this one. We'll go with the Pythagorean identity. So obviously this side right here is a little bit more difficult than the right side. So secant squared theta minus 1 is equal to tangent squared theta. Okay, so that was using the Pythagorean identities. Okay, so we got here from the Pythag. So we got here from the Pythagorean theorem identity. Okay, so tangent squared over secant squared, we don't really have any rules in order to kind of simplify this. So last case scenario, you can always turn things to sines and cosines. So tangent squared theta in terms of sines and cosines will be sine squared theta over cosine squared theta, and secant squared theta will be 1 over cosine squared theta. So what we'll do, and again, we did this using the quotient identity, And this one was the reciprocal identity. So what we're going to do is we're going to keep change flips. So we have sine squared theta over cosine squared theta. We're going to change the sign in the middle, and that's going to be cosine squared theta over 1. And that, after canceling out, is just sine squared theta, which was what we were supposed to be getting on the other side. Now, for our last one, it's a little tricky. Okay, so what you need to know here is you need to know that I would start with the right side here because, again, we have fractions and everybody does not like fractions. So what I'm going to do first, I'm going to take these out of the fraction. So 1 over cotangent to the 4th of a is really tangent to the 4th of a, and 1 over cotangent squared a is really tangent squared a. And now we don't have fractions. And what we did here is we use, of course, the reciprocal identities. Okay, so what I'm going to do is I'm actually going to factor out a tangent squared a here, because now I'll have a tangent squared a plus 1. And what is tangent squared a plus 1? Well, that is secant squared. Okay, so it looks like we got really nowhere here, but we have really simplified it. And what we're going to do with the other side is we're going to look to the other side for a little bit. So what we're going to do is we have secant to the 4th of a minus secant squared a. They both have a secant squared in them, so I'm going to factor that out. So now I have secant squared a. So now I'm left with secant squared a minus 1. Now we know that from Pythagorean identities, secant squared a minus 1 is just tangent squared a. So now, if I just flip these around, I'll have tangent squared a times secant squared a is equal to tangent squared a times secant squared a. We have proven that both of these sides are equal, therefore, we are done. Okay, so I know this will be difficult for some at the beginning, and I can definitely give tips and tricks as you go through your problems. You're going to have to do more in order to get better, though. That's one of these things that you have to practice. It's like puzzles. The better you get at them, based on the more you do. Now, before we end this, I did say that there are 3 different ways to prove, and the other 2 is graphically and identify numerically. So for graphing and verifying the identity, you want to show that each side of the equation has the same graph. So what we would do here is we'd enter the left side of the equation into y1 in a graphing calculator, and the right-hand side equation into y2 in a graphing calculator. And when you look at the graphs, they should appear to coincide, which means they would probably look to be the exact same graph. You can do this on Desmos to prove your answers, or if you have a graphing calculator at home, we can find out how to do that on your calculator. The other way to do it is identify numerically. So you'd want to show that for every value of x makes the equation true and it makes both sides equal. To verify this, after typing both sides of the equation into your calculator, you can look at your table or you can just put them in numerically. So what I'm going to do here is, in example number 16, we have that last problem that we just did, and I'm going to make y1 secant 4a minus secant squared a, and we'll make y2 1 over cotangent a plus 1 over cotangent squared a. Now, you could put these both in your calculator. You could also put the values in. So if you put in 10 for secant if you put in 10 for a, for both of those numbers, you would get 0.597. Okay. If you put in 20 for these a's right here into your calculator, you would get 30.054. If you put in 30 for both of these a's here, you would get, what is that, 1,724.3. Okay. Now, if we wanted to look at y2, we would put 10 in for these a's, and you would get 0.597. If you were to put 20 in for both of these a's, you would get 30.054. And if you were to put 30 in for both of these a's, you would also get 1,724.3. And you have now shown that these are all equal, which means we can verify that secant to the fourth a minus secant squared a is equal to 1 over cotangent to the fourth a plus 1 over cotangent squared a. Okay, this is a great way to verify things if you are unsure if they're actually equal. But most of the time you will be verifying algebraically. So this is actually the end of today's notes. If you guys have any questions or concerns, please see me in the meets. If you guys get stuck, again, I can help lead you in the right direction depending on where you got stuck in the meet. You can also send me an email or chat with me through GoGuardian. I hope you guys have a fantastic day. And again, please reach out to me if you're having any questions.